Hi apes, today we're taking a look at Unit 5, Part 5, which is going to focus on fisheries, or how we get our food from the oceans. Now here, this diagram just shows a couple of things. This picture up here is just to show you the scale. This is a very large boat, and this is likely a purse seine. This is one of the methods we'll talk about that is able to capture giant schools of fish. And this is what it looks like once you bring it up on the boat. So these nets are just filled with fish. Now, one of the ways that we get food from our oceans is literally farming in our oceans. And we call this aquaculture. So this is farming in the water. Now, this tends to be a very efficient way of getting our food because there's very little land use. There are some times where you might farm on land in giant pools. But a lot of times we are using the ocean as its own location. And it tends to have much lower fuel use than our traditional agricultural methods. Now, some of the most common ones we farm are shrimp, and that's what this diagram is down here. This is a shrimp farm. So these pens would all be filled with shrimp, and you're using the natural flow of the ocean to help provide some food and some filtering of water. We also will farm oysters, and those would be the oysters don't move, so they would be in one section of usually of a bay or of a river. And we can also farm fish, and those would also be in either pens like this or fish on land. Now, one of the problems with this is the amount of waste that is created. Now, in particular, something like shrimp farms, one of the big places they do this is in mangroves because it's nice, calm, protected waters. And so what's happening is that when we do this shrimp farming in mangroves, it creates a tremendous amount of waste that can harm the plants and harm the communities that make the mangrove their habitat. Now, when you have a high volume of these critters living in these pens, one thing you see very similar to meat farming is that you often do have to use a lot of antibiotics because of that factor of disease being a density-dependent factor. So we do have to use antibiotics that might combat any disease that would spread. Now, one thing that we need to know is understand exactly what a fishery is. So a definition of a fishery is it's a harvestable population of fish or shellfish. Now, this is often a great example of tragedy of the commons if we take too much fish out. In particular, fish in the open ocean, because multiple countries could be going after similar fish and not be communicating how many they're taking out. And this is a very good example of why our whale populations declined so rapidly, because they were overfished. We took too many out and did not give them a chance to reproduce. So if you take a look at this graph right here, it tells you the number of species that are collapsing. And this doesn't mean that the species are going extinct. It just means that they're no longer harvestable at an economic level. So our global fisheries from 1950 projected out to 2050, you can see are definitely on a downward trend, and this is due to overfishing. And this graph over here can help to describe why. That here we have the blue line is our per capita catch, and if you remember, that's per person. And this red line here is just increasing from 1950 projected out. And so what's driving this increased need for the catch, even though our per capita has not increased much, is our increasing world population. Fish and seafood are a very good source of protein for a large portion of our population around the world. And so you're seeing a higher need of this fish and a higher demand. So that's why we are overfishing our fish. Now, one other reason why we're overfishing our fish is because it's become very easy to overfish our fish. Now, up here we have some diagrams that show how we can get our different types of fish. So, numbers 4 through 6 are what we refer to as trawling. So this is a bottom trawl right here. And so this is a cone-shaped net that you drag along the bottom, and it'll catch anything in its path. Here, this is a mid-water trawl right here. And here's another lower level trawl. So this scrapes the bottom, this catches the fish above, and then this one right here is a mid-water trawl. So essentially what these are is these are cone-shaped nets that are dragged behind the boat and it captures anything in there. So the fish will just swim right through there and it'll get caught right in there. Now trolling is number 7. This is a lot smaller scale where you just have baited hooks that you drag behind your boat. And this is the picture that was in our introductory slide. This is a purse seine. This is used to catch large schools of fish. What you do here is they will drop a net in when they see a school of fish, and they'll encircle them with their boat, and then they'll be able to pull that net up from the bottom. So this captures huge schools of fish. Number 9 here is the gill net, and this you can put at different heights in the water. And with the gill net, what you see is that fish will go up to it, and this is right here as well. This is the gill net. Fish will swim up to it, and they won't really see that mesh in the water. It's nearly invisible, and they'll swim in and they'll get stuck in that net, and they'll just struggle and struggle until you pull that net up. So this is a good way to catch fish, but you can catch a lot of things that you don't intend to catch in here as well. So let's say a dolphin gets stuck in there and they won't be able to get to the surface to breathe. So all of these methods have some unintended catch, and those unintended catch, that's what we call as bycatch. And we'll talk about that again in a minute. But the thing about these is that they are all blind catching. So these trawl nets, they just catch whatever it is. A bottom trawl, what this will do is it'll tear up the bottom habitat, so it'll scrape the bottom and destroy any type of bottom habitat. And all of these nets just indiscriminately will catch the different types of fish. Now number 11 is longline fishing. This is a big one we do for, say, swordfish or tuna. And what you do here is it's literally miles of baited hooks. And you just leave them out. So you drop the hooks and you leave them out sometimes for a day or two, and then you reel it back in and see what you've caught. So our technology really has increased our ability to catch a tremendous amount of fish. So how we help to control it and make sure we're not overfishing too much is, one, we do size limits. We need to make sure that the fish are big enough and therefore old enough to have reproduced. So we make sure that the fish that we're catching have already been able to reproduce and actively add back to that population. We have catch limits that are quotas. So within our quotas, we might say that, okay, we know how much fish are out there about, and so here's what we can do and keep this at a sustainable level. And how we determine that is by using either the MSY or the OSY. Now the MSY stands for the maximum sustainable yield. So what this means is it's the most you can take and still have a sustainable fishery. And typically what we use to estimate the MSY is that it's 1/2 of the carrying capacity. So if you remember here, our logistic growth curve comes on up here. So here, our example, the carrying capacity looks to be about 100. So the MSY is estimated at about 50. Now, if we are correct on this, and our estimate is correct, you capture 50, that leaves 50 behind to reproduce. The next year you will have 50 again, and the next year 50, and this would continue on sustainably. But the problem is that we're not always right about the MSY. Let's say the actual carrying capacity is 90. So if your carrying capacity is 90 and you take out 50, that leaves 40 behind. So the first year you might be okay, that doubles to 80. And you take out 50 again, which you're assuming is your MSY. That leaves you at 30. That doubles to 60, and you take out 50 again, and pretty soon your fishery has crashed. And so a little bit of a better method to check and to set your catch limits is the OSY, or optimum sustainable yield. Now the optimum sustainable yield is just something a little bit below your MSY. It just gives you a cushion in case you're wrong, in case you are off on your estimate of the carrying capacity, in case they didn't reproduce the way you think they do, in case there's an introduction to a new predator, in case there's a disease. It just gives you a little bit of a cushion so that you don't overestimate your population and lead it to ruin. So if you set your OSY at 40 and you actually had 90 and you take out 40, you have 50 left behind, that doubles to 100. So by giving yourself a little bit of a cushion, you actually see your population growing rather than crashing. Now, the signs that you are overfishing, one big thing you see is that it's harder and harder to catch these big fish. So the fish that we're seeing are shifting to smaller and smaller. Now that also means that they're younger and they haven't had time to reproduce. And that's a key thing, is you can't take fish out unless they have had the ability to reproduce. Now what we're also seeing is that it's very difficult to get these top predators that we tend to like to eat, like swordfish and tuna. So what we start to do is now we're targeting lower on the food chain. So we're shifting our diet so that we're eating lower on the food chain because there's more of them. Because remember our ecological pyramid, that because of the second law of thermodynamics, that there are more of these lower on the food chain by biomass than our top predators. Now, one of the driving reasons behind this overfishing is that unintended catch that I referred to early on, and that's bycatch. So our unintended catch are the things that you accidentally catch in your nets that you don't mean to, and oftentimes you just have to throw overboard. So this picture here, clearly they were not going after that shark. We tend to not eat shark in this country. So they caught all these fish and they're going to throw that shark overboard. Now here, this could have been a turtle that got caught in a net. Could be a seine net, could be a drift net or a gill net. And sea turtles are endangered species. They are protected, so we can't sell it, we can't eat it. It unfortunately probably drowned and died, so the only thing to do is throw that one overboard. And over here, this one was clearly a bottom trawl because you see all these bottom critters, but we don't eat sea stars, and so those would have been killed, but would have to be thrown over. So bycatch really is a problem. Now, one thing that we've tried to do to prevent bycatch is to create ways in our technology that will allow larger animals or larger mammals that we're not going after to escape. Now, here's a picture of a trawl net. And in this trawl net, you can see that this turtle has a trap door that allows it to escape. And so the turtle gets caught in this trawl net and is able to trigger this escape door. And they call this a TED, a turtle exclusion device. So this is just one piece of technology that has been developed to try to help eliminate this bycatch. Now here you see a dolphin that got captured in a probably a gill net. And one thing they do here is they, what you might see on some nets is they might put pingers on there to send out a sound that our marine mammals are particularly sensitive to, and that might help them to avoid it. Another thing you can do to avoid bycatch is to set your nets at certain levels. So a lot of times fishermen are very, very knowledgeable about the habits of their catch. So they can set their nets at the appropriate level to target where they are and maybe avoid some of these marine mammals. So there are steps we can take to control our fisheries, but we do have to focus on setting limits, setting size limits, and trying to reduce bycatch.